Hello student, good morning. Today we will start the chemical mutagens. Chemical mutagens. Although radiations has been proved to be damaging to biological system, if misused, many geneticists feel that chemical mutagens are more hazardous to man than radiations. The possible sources of chemical mutagens are unlimited. The list of chemical mutagens become longer with every passing year. However, the most powerful chemical mutagens are mustard gas, Batch and Robson and its related compounds. Ethyl urethane, formaldehyde, mutagenic in Drosophila. Fourth, organic peroxide, mutagenic for fungus. Ferrous and manganese salt, Demers and his colleagues, highly mutagenic for bacteria. And last 6 number, LSD, lysergic acid dimethyl amide. When ingested in moderate doses, does not damage chromosomes, but large doses are considered to be carcinogenic and teratogenic. The sleeping pills made of thalidomide, when taken by pregnant mothers, results in the birth of deformed newborns with no arm or with flippers. Increased use of drugs, pesticides and the chemical preservatives and coloring agents added to his foods are a threat to the human populations, as their mutagenic nature cannot be ruled out. Spontaneous mutation. Spontaneous means naturally, suddenly. Mutations are said to be rare, and thus the mutations in a gene are too rare. However, most organisms have many genes, and the total frequency of mutations in all genesis is substantial. The data are most abundant for sex-linked lethals in Drosophila melanogaster using CIB method. The CIB method. The mutations are of many kinds. In general, mutations may be classified according to whether they produce number 1, visible change such as red to white eyes, or second, lethal effects. X-rays produce lethal in all chromosomes of Drosophila, but our study will be restricted to those lethals which occurs in the X chromosomes. Muller devised a technique for the detection of new lethal in the X chromosome of Drosophila. This technique is known as the CIB method. It involves the use of females in which X contains a crossover suppressor, C receives lethal I, and the dominant gene bar I is capital B. The other X is normal. The female fly which contains the above characteristics is known as CIB female. When CIB female is crossed with treated male with X-ray will produce one the bar daughters which contains the CIB chromosomes derived from their mother and also the treated X from their father. When bar daughters are crossed to any male in F2 generations, the half of their sons receiving the CIB chromosomes die. The other half receiving recessive sons which get the treated X chromosome will also die. If the treated X contains lethal, but anyhow all the daughters will survive because they receive the normal X chromosome from their father, any male. In this way, if an F1 CIB female produces daughters but no sons, it indicates that the must have received a lethal from her treated father. If we perform the two sets of experiments, one with treated male and the another with untreated or control male, and if we found that there is significant larger number of the lethals in the treated series in comparison to the control, it can be concluded that the treatment was producing lethal mutation. If, however, the treated X had contained a visible mutant, then the mutation would show in the CIB method is very appropriate for detecting any type of mutation either visible or lethal. Normally, genes are extremely stable structures, yet mutations have been occurring in nature all the time in spontaneous manner. Although mutations are rare and occurs at random, they have an advantage in providing a constant source of new variability which is required by organisms to adapt to the changing environment. There are numerous physical and chemical agents which can increase the frequency of mutations. If a mutation is dominant, it is easily detected because it is always expressed by, but mutations are exceedingly rare. The mutant's gene which causes aniridia, absence of iris in human eye, is dominant over the normal allele. Rare of frequency of mutations in individual genes. Rate or frequency of mutations in the individual genes. Different genes are not equally mutable. In Drosophila, mutations. Two white and two vermilion eyes have appeared many times. Rare or spontaneous mutation in Drosophila after Wagner and Mitchell. Organisms Drosophila melanogaster gene YWIZ. Number of gametes testes Y 70,000, W 70,000, IZ 70,000. Mutations frequency per 10,000 gametes 0.29, 0.29 and 0.29. YW and IZ 0.29. In the above table, the spontaneous mutation in Drosophila has been given. Mutation. This is the chemical mutation. Okay, remaining part we will be take in the next lecture. Okay, thank you.